After 42 years working as a professional chess journalist, a speaker, and trainer in educational chess for more than 30,000 school teachers in more than 30 countries, many people is asking me, how are you able to get up every day with the same passion you had 42 years ago? The key point is that thanks to chess, I have learned a lot about many very interesting fields of human knowledge which are connected to chess. One of them is artificial intelligence, another one is education. So now for the next 20 minutes or so, I kindly invite you to be back and become children or teenagers again, because what I'm going to do now is to demonstrate how you can use chess in the classroom as an interdisciplinary tool to explain the history of artificial intelligence. And then at the end, you will see that the title of the lecture is not exaggerated. So, in order to create a nice atmosphere in the classroom, I will start explaining the legend of wheat grains. As I don't have time to explain now the whole legend, let me tell you just the very basic things. The chessboard has 64 squares. We put 1 grain of wheat in the first one, 2 in the second, 4 in the third, 8, 16, 32, 64, 128, 256, 512, and so on. We are doubling until the square 64. At the end, we have these huge magnitudes. And that's why I am starting my class for my students with these big magnitudes. Actually, I don't know how to read this in English, because in Spanish, 1 billion is 1 million of millions, but in English, 1 billion is 1,000 millions. So in Spanish, that will start saying 18 trillions, but in English, I don't know. But it doesn't matter, because for you and for me, this number is close to our concept of infinite. Okay, you will need 8 million very big ships to transport that wheat, and if you put all those ships in the sea, then you will need 17 times around the Earth for the ships to transport that wheat. Now, following the same idea, I will emphasize that for centuries, the most prominent inventors were obsessed with the idea of creating a chess machine, a machine able to play chess. That takes us to the 18th century. Mr. von Kempelen in the Austrian-Hungarian Empire was able to create a machine which was playing chess. I also recommend you to read the whole story, because it's extremely funny. But the basic thing is that, of course, that machine had a trick. It was a fraud. A very strong chess player was hidden inside. Okay, now let's go to the core of the story. Those two, Alan Turing and Claude Shannon, can be considered the main fathers of computing and artificial intelligence. From the very beginning, that means around 1947, they thought separately, one was in the USA, the other one in the UK, that chess could be a very interesting field of experimenting artificial intelligence. Why? Well, in the concrete case of Alan Turing, we have to know something which is very interesting. Maybe you have watched this movie, Enigma. We have to come back to Buenos Aires, Argentina, 1939 Chess Olympiad. Suddenly, the English team has to withdraw the Olympiad because the Prime Minister, Winston Churchill, is calling and ordering them. The three the strongest players of England were Golombek, Alexander, and Milner Barry. The three of them had to fly back urgently to London to meet Alan Turing for a very secret task, which was to understand or to break the secret code of the Nazis for the communication. They were successful, and that's why they saved, according to the experts, probably they saved several millions of lives, and the Second World War was much shorter than expected thanks to that. So that means that Alan Turing was already used to work closely for a long time with grandmasters, chess grandmasters. But the real thing is this one. Both Turing and Shannon realized that the number of possible chess games you can play is bigger than the number of atoms in the whole known universe. So they thought, if we are able to create a machine, a computer, which beats the world chess champion, that is going to be a very difficult task because having in mind those very big numbers, we cannot achieve this only with brute force. We will need artificial intelligence indeed, because no computer then and no computer today in 2025 is able to control such a big number. Therefore, well, we are talking about this kind of magnitudes. The number of atoms in the known universe is 1 followed by 80 zeros. The number of possible chess different games is 1 followed by 123 zeros. And Go is a very popular Asian Asian board game. And the number of different games is even bigger, 170 zeros after the 1. I'll tell you later on why I am including Go here. Okay, then how much time do we need to achieve this goal? A lot, probably much more than they expected. It was 50 years. And why it was 50 years? Well, I understand that many of you are not chess players, so I'm going to explain this with a very simple language, 2 examples that everybody can understand. It is very easy to explain to a computer that this piece, the queen, has a value of 10 points. 10 points. The rook, 5 points, bishop and knight, 3 points, the pawn, 1 point. Okay, but in this particular position, let me go. This queen here is practically useless. The value of this queen is not 10 points because it's surrounded and blocked by her own pieces. It can go only from A8, where she is now, to here, to A7. So in order to get this queen with a real value of 10 points, you have to move all the other pieces to reorganize the whole position, and then the queen will become active, and then the value will be again 10 points. It is extremely easy to explain this to a 7-year-old girl or boy who knows how to play chess, because it's human logic. But how to explain this to a computer? It took a lot of years, because the computer only understands a binary language, zeros and ones, that's all. And explaining this to a computer took a lot of time. The second example was this one, the horizon effect. The same 7-year-old boy or girl will immediately understand that this position is almost winning for white, because this pawn going forward to here will be converted in a queen if it gets to the 8 square, to the end of the board. So there are no black pawns avoiding or stopping this pawn to go to that square. Explaining this to a computer was very difficult because the brute force was still low. And then the computer will only understand that that pawn is very dangerous when actually it calculates all the moves and replies from black until this pawn gets to a7 to go to a8. That was also a very difficult process. Okay, but 50 years later, I was there. Kasparov, probably the strongest chess player in history so far. He was #1 for 20 years in a row. Lost to Deep Blue. Deep Blue was created by IBM. And then IBM dismantled Deep Blue, and they demonstrate that Alan Turing and Claude Shannon were absolutely right, because they used what they have learned by beating Kasparov on several fields where the common factor is molecular calculation, like production of complex medicines. I mean, when we go to the pharmacy now, sometimes we are getting benefit from what IBM learned by defeating Kasparov, or stock exchange calculation, weather forecast, agriculture planning, etc. Okay. Then this man, Demis Hassabis, was graduating himself in Cambridge University. He had been already a prodigy child in chess, #2 in the world under 12 after Judith Polgar, but fortunately for the mankind, when he had to choose between chess and science, he chose science. And he was by then kind of obsessed with how to improve the way IBM had programmed Deep Blue. 3 years later, he was the CEO of DeepMind. DeepMind was bought by Google, and they first created AlphaGo. AlphaGo was able to beat a very strong Go player, the Korean Sidol. Then they created AlphaZero. AlphaZero was playing chess, but, and this but is with capital letters, completely different than Deep Blue. Deep Blue had inside, as I have in my laptop, for instance, 10, 11, or 12 million of human chess games played from the 16th century until 1997. But AlphaZero had no database at all. What they did with AlphaZero was the machine played millions of games against itself, learning through the process. Then they organized a match between AlphaZero and Stockfish, which was and still is one of the strongest chess machines, chess computers in the world, programs in the world. And the result, you can see, is quite convincing. AlphaZero 27, Stockfish 0. Then the big question was, will there be transfer to more important fields of science, as Alan Turing and Claude Shannon predicted? And the answer was a very big yes. Because 3 years later, they created AlphaFold, and AlphaFold was able to understand the structure of proteins. Why is that so important? Well, protein is a very basic element for life. Proteins are composed by amino acids. There are more than 3,000 amino acids. The possible combinations of 3,000 amino acids makes a very big number. You remember big magnitudes? That's why learning from chess was so useful to achieve one of the biggest discoveries in the history of biology. The big experts said before that happened in 2020, before that they thought that it was going to be impossible until the 22nd century. And why is this so important? Also because thanks to this, the last discoveries against liver cancer were amazing. It also happened with antidepressants. And according to Demis Hassabis himself, right now there are more than 500,000 scientists, researchers, working on trying to take advantage of this big discovery related to proteins, working in many different fields of science. So that's why Demis Hassabis and 2 members of his team got the Nobel Prize last September. That Nobel Prize is very connected to chess. And Goethe, in my view, you can read his biography, is one of the most cultured human beings in the history. And he said, chess is a touchstone for human intellect. I think the Norway chess organizers realized that many years ago. That's why, besides a very innovative chess tournament, they are holding this conference. And I hope that my lecture has modestly contributed to that goal. Thank you very much.
Leontxo, I have one important question for you, though. So this is all great, AI, cancer drugs, antidepressants, but full circle, how has AI, which benefited so much from chess, how has AI hurt chess?
Yes, cheating. Cheating is a big problem for chess, especially playing online. But let's talk about the future. According with the big experts, in about 7-8 years' time, our brain is going to be connected to a chip. The first step will be through some device, glasses, hat, whatever. Then they will insert the chip in our brain. That will be, of course, extremely good for detecting cancer, for instance. But that could also be terrible for many other purposes. What about chess? I think my prognosis is the chess arbiters, the professional ones, will be obliged to add a new tool to their professional typical tools. That tool will be a detector and blocker of brain chips. So you are a participant in an open tournament, and then this is the entrance, and then the arbiter will scan your brain when you go to the playing hall. Because otherwise, chess as a sport will be death. But with this, I hope that chess will be forever. And don't forget something. Even if the best chess player in the world right now is not a human being, it's a machine, in most of the cases, I will say 90% of the cases, in chess, beauty is a doctor of mistakes. I play a game with James. I made I make a mistake, and James finds a very beautiful combination, punishing my mistake, and we both are creating beauty. So the future of chess, and especially the future of beauty in chess, will be in human being hands.
Well, thanks very much, Leontxo. Very good.